Hello grade 12s, welcome back to another video. So today I will be doing organic chemistry. Now, what is organic chemistry? Organic chemistry are molecules that consist of carbon. So the center of these molecules has carbon in all of them. Now, carbon is the backbone of organic chemistry. Molecules. Now, when we say organic chemistry is a molecule that consists of carbon, carbon is an element, right? One of the elements on the periodic table. And elements can also be called atoms, right? Another name for an element is an atom. So the carbon, here is the carbon in the periodic table, has a mass of 12 and electronegativity of 2.5. So that's carbon. So in the center of these molecules, we have carbon. And a molecule is two or more atoms connected by chemical bond. So in this periodic table, let's say we bring oxygen and nitrogen together. They make a molecule. Or we bond oxygen, nitrogen, and carbon. That is also still a molecule because the definition of molecule says two or more atoms connected by a chemical bond. They form a molecule or a compound. We can also use that word, molecule or compound. So we have three types of bondings. We have covalent bondings, which is number 1. And covalent bondings are bonding between two non-metals. So you are in grade 12 and now you should know metals and non-metals. So from this C going this, I think it's from here. Yes, from C, P, S, E, like this. All these elements that appear in here are all called non-metals. They're all called non-metals. And this one here, we have semi-metals, and then from there we have metals. But for organic chemistry, we only focus on non-metals. So all of these elements that appear here are non-metals. So when we have all two or more of these elements or atoms bonded, we have a covalent bond because we will have things like oxygen, fluorine, neon, nitrogen, sulfur, chlorine bonded together, and they are all non-metals. And then we also have ionic bonding. Ionic bonding is bonding between a metal and non-metal. And just before we forget, hydrogen is up here but is also part of non-metals. Now we have things like lithium, beryllium bonded. They are metals. Sodium bonded with oxygen, hydrogen, nitrogen. We have non-metals and metals bonded together, and we call that an ionic bonding. So metallic bonds, it's a single metal. Yes, so we've learned about the 3 types of bonds, and in this chapter, we are gonna be specifically dealing with covalent bonds. And when atoms bond together, they become more stable. So when you combine sodium and magnesium and maybe throw in some potassium, they become more stable. Or when you combine sulfur and chlorine, they both become more stable when they have bonded together. And in grade 12, we will be doing 9 homologous series. And homologous series is a family of hydrocarbons with similar chemical properties who share the same general formula. And today we're going to be doing how do you recognize this homologous series. All right, and the first one that we'll be doing is alkanes. So alkanes are single bonded carbons and hydrogen atoms. Now, in order for you to be able to identify a molecule structure, or in order for you to know which one is this one, you need to know the functional group. So for you to identify alkanes, you need to see you only in the structure, you only have hydrogen and carbon single bonds. So you only have hydrogen and carbon single bonds. A single bond is seen by this one line. If it's a line like this, is a single bond. If lines like this, carbon and carbon, or carbon and hydrogen, these are double bonds. And then if we have the third one like this, these are called triple bonds. So when you have single bonding hydrogen and carbon, know that you are working with alkanes. So the name also ends with A and E because alkane stands with a name ends with A and E. So S means there are different types of alkanes. So yes, that is how you identify. So know the functional groups. And the second one is alkenes. So for alkenes, we have molecules containing a double carbon double bonds. Sorry, it's the carbon double bonds. So in that molecular structure, you will see something like this, where these two carbons have a double bonding in between. Now alkenes end with en, so this is how the name will end. When you start naming this series. And then we have alkanes. So this one contains at least one carbon triple bond. So just know from the beginning, we have carbon and hydrogen single bonds. Alkanes, and here we have double carbon bonds. And on this third one, we have triple carbon bonds, right? In the structure, you have to look for where you're having triple carbon bonds, and you know which one is this one. And then the name starts with Y and E because this name ends with those 3 letters. And then we have, for number 3, we have alcohol. Alcohol has 2 covalent bonds of between oxygen and carbon and between oxygen and hydrogen. So the functional group, we see it's O, C, and O and H. So there's a bond between O and C and O and H. They can be written like this, O, H, or they can be written like this. So when you see OC and O, you know this is the functional group, and you know that this structure definitely belongs to alcohol. And the name ends with OL. Keep that in mind. When we are naming them, you will know. And then we have haloalkanes. This is a group of chemical compounds comprised of alkane with one more hydrogen replaced by a halogen atom. So the alkane is the first one we did. It's carbon and hydrogen bonds, but we will add one. And then we'll add one halogen atom. So halogen atom is the group 7 atoms on the periodic table. Let me just, where did I put my periodic table? So this is the group 7, this is the group 8. So we have, this is fluorine, chlorine, bromine, all that. These are the group 7. So any of these atoms can be one of the single bonds here. So we have CC. This is a CNH, which is alkane, which is an alkane structure, but you will just have, they just throw in this halogen atom, which is B, which is bromine. But they can also do F, they can also Cl, I, AT, and TS. So you can have between those ones. And the name ends with O, with 1. Yes, because haloalkanes, so its name ends with not 1, A and E. Sorry about that. The name ends with A and E. And then we have aldehyde. So the 6th one is aldehyde. They have double bond oxygen and carbon. I didn't see that. I didn't, the camera stopped working. I don't know where, but we have alcohols here and their functional group is here. So alcohol, this is a 2 covalent, it has 2 covalent bonds. So we have oxygen and carbon, and then we have oxygen and hydrogen. So you just know by seeing OC and OH single bonds. The name ends with OL, that's alcohol. The functional group is OC and OH in the structure. So haloalkanes, a group of chemical compound comprised of alkane with one more hydrogen replaced with a halogen atom. I said the halogen atom is part of the group 7 atoms. This F, Cl, Br, I, and At. Those are the group 7 atoms. So it can just be included there. So here they've just included the Br. So it can be Cl, LAT. Whenever you see something that is not hydrogen, carbon, oxygen, and you see something different, just know that is haloalkanes. And the name ends with A and E. And then we have aldehydes. They have double bond oxygen and carbon. So when you see this, a double bond of oxygen and carbon, just know you're dealing with aldehydes, and that's the functional group is double bond oxygen and carbon, and the name ends with Al. Easy, right? The next one, we have ketones. Those are water soluble molecule. They have double bond oxygen in the middle. So the functional group, you have to see double bond oxygen. Yes, not H. This is oxygen, double bond between oxygen and carbon. And the name ends with ONE, 1. And then we have carboxylic acid. Carbon with double bond oxygen and OH. So it's H, it's carbon, there's double bond oxygen and OH here. Or it can be like, it can be written like that, O and then H, single bond carbon, then single bond oxygen, not OH. there has to be a double bond first. So here we'll tell you about the functional group of carboxylic acids, and the name ends with anoic. And then we have esters. So ester is when you take your alcohol and your carboxylic acid and combine them, you are going to get ester. So we have for carboxylic acid, remember, is double bond O, and then for alcohol, yes, with esters, you're going to have a double bond C and a CO. So this is how you know that this is an ester. You need to have this functional group, double O, and then double bond O and single bond O this side. Then you know that is an ester, and the name ends with, this is what the name ends with. Thank you very much for watching, guys, and in the next video we will try to name structural formulas. Thank you very much for watching.